Here we go. This is number 1. It shows the number down at the bottom, but I have to zoom in to make this. This is number 1. I'll do this, okay? There are 11 questions. This is number 1. This is homework help for lesson 5.1. It is due tomorrow, which is the 26th, January 26th. Write the radical expression as an exponential expression. So we want to write the square root of 13, but with exponents that means the same thing. What exponent represents the square root of something?
Wait, what?
You go ahead and tell me what you were going to tell me.
1 over something.
No.
What?
Yeah.
There's no.
Yeah. The exponent 1/2 is the same thing.
That's what I said.
You said 1 over something.
Yeah, because like it could be 1 over 5, 1 over 6.
Oh, I see what you're saying. I mean, I specifically said the square root, but that would be the answer if I said the root of something. You would say, yeah, it would be the exponent would be a fraction, 1 over something. Okay, so yes, you were on. I thought you were getting that confused with like negative exponents where you put it in the denominator, so it's 1 over, but I understand what you were saying now. So because this is saying the square root, now how do we know it's a square root if there's no 2 here? Yeah. It's an invisible 2. So if you'd like to make that 2 show up, you can. But if you don't see a number for the root, it is the square root. So the square root of 13 can be written as 13 to the 1/2 power.
Now if
That's it.
If it's 1/2, like are we
Wait a minute.
Oh, sorry guys. But can we put the 1 in the house?
Like this?
Yeah.
Yes.
Okay.
If you want to make that one show up too. Yeah, we could.
Wait, how do we enter that?
You don't. You
I'll
can't,
show you.
Oh, you hit the.
It involves a bunch of buttons. So the first thing you have to do,
I know how to do it.
okay, the first thing you have to do is show that you want to write a base and an exponent. So you click this button. Can you see that? Down here, the base and the exponent. Oh wait,
Wait,
I lied.
I thought we were friends.
No, hold on.
Would it be the
First,
same thing?
I think first you write the number, so 13. Then you have to show that you want to do an exponent. Then once that you have the exponent there, then you have to hit the fraction button to show that you want your exponent to be a fraction. And then you hit the 1 and then the 2. Do you want me to do that again? Or do you guys have
It would be
it?
the same thing. I have 10.
What?
If my number's 10.
Yeah, it would be the same thing, but it would be 10 to the half. Yeah, keep in mind that your numbers may look different. The process is still the same. If you need help with your numbers, just let me know. All right, let's do number 2. So these are very similar. The first couple of questions are pretty much on the same topic. So the cubed root of 10, this is number 2. The cubed root of 10, how can that be written with a base and an exponent?
10 to the 3rd power.
Yep, 10 to the 1/3 power. If you have a different base or a different root, you would have to adjust your answer to match your base and your root. Ready for the next one? Did I hit record? I always,
Yeah.
I did. Okay, always. Yeah. Your computer's not working? Well, can you just like take really good notes and then you can do it later?
Abby.
All right, let's try this one. This is number 3. Girls,
Oh, there we go.
this is number 3. The 5th root of 3 squared. How do we write that with exponents? That's exactly what it would be. 3 over 2 2/5 power. Not 3 over, 3 to the 2/5. Because the root is our denominator and the exponent is our numerator.
What? What the what? Where did n come from? I'm on number 1, but it said I got it wrong. Because it wasn't working. It says a is 1 over n. Where did that come from?
Are you on the right
Abby,
one?
it's telling you why it's incorrect. It's not telling you numbers, it's telling you letters instead of numbers.
But that's what you guys got. Oh, so
Why doesn't your why
No,
is your
I
computer that broken, Abby?
no, I switched it because I kept on clicking the power.
You guys ready for number 4?
No.
Yeah. Burn off your bleeds.
So
Actually, could take your DNA.
Oh,
Abby's mom's girl wanted to pay $300.
she doesn't see my computer yet. She won't.
So the front office.
All right, number 4. Abby, after the video's over, I can go back and help you with the ones that you missed, okay? But skip to number 4 for now.
Okay.
Number 4, the only thing different about this one is what?
It's negative.
Yeah, there's a negative number involved. It's okay, we're just gonna do the same exact process. So our base is going to be 2. We're doing the one up here first, you might have different numbers. Up here, the base will be 2. My exponent will be what?
Negative 5 over 4.
Yep, negative 5 over 4. Very good. And then you'll just have to do that just like you would put a negative fraction in. Let's see.
Okay, so we do.
So if I put my 2 here, and then I go down and do my exponent button, then I do my fraction button, I'll just do negative 5 over 4. Now, is there a way to do negative and then 5 over 4? What if I do, whoops, okay. What if I do the exponent button and then click a negative and then click a fraction? Let's see, does that work? Yes. Now it makes the entire exponent fraction negative, which is what we want. The other one, it will accept that answer, but this is technically the proper way to write it. So it'd be negative 5 over 4. Nice, weird. Everybody get theirs done?
Yeah.
Okay. These are pretty easy, right?
Yeah.
It is nice.
It'll get a little more, like, there are a few more that are this easy, and then I think it's like the last 2 questions that just require a little bit more work. Okay. So now we have, this is number 5. What's our base?
3x.
X. And then what is our root?
3.
Nope, that's our exponent. What's the root here?
1.
It's an invisible.
1. 0.
What's the invisible number here?
0, 1.
2.
2, yeah, remember we talked about that just a minute ago? That there's an invisible 2?
I wasn't even listening.
Whenever there's a square root sign that doesn't have an index here, the invisible number is 2. So how would we write that as our fraction?
3 over 2.
3 over 2, very good. You can apply that to whatever numbers you have.
Oh, I was about to get that wrong.
Looks like.
Yeah.
What question are we on?
Yep, now we're doing 6. Same process.
What? Oh, I know how to do this one.
Number 6.
What?
Emily's hand was up first, so Emily, go ahead. What's my base? Okay. And what's my exponent? Y over 7. Very good. B to the y over 7. Now you can apply that to whatever you guys have. Do you need help, Abby?
It ain't working.
She definitely.
All right, ready for number 7? fastest homework we've ever done.
Oh, what? Wait a minute. This is wrong. This is so wrong. It's wrong.
Tell us how you really feel, Abby.
No, Abby, that's right.
Oh, here we go.
Yes, it is.
You know how to do this?
I do.
Okay.
I did it.
You did this one already? Okay, let me try Emily first. Then. Is this number 7? Okay.
The expressions aren't equal because they don't
They don't? Okay, I don't know because I can't tell from just looking at them. Use the properties of exponents to determine whether they are equivalent. Now, did you determine that by just punching them into your calculator? Okay, so the directions say to use the properties of exponents. They want you to break it down to see if they will mirror each other, that they will look exactly the same. Because they don't look the same, but they could be the same. Do you think they're not the same thing? Okay, you might be right. It generates new numbers. I can't tell just by looking at it. Yeah.
They are equal because they both equal 15,625.
Okay, so you also use your calculator?
Yeah.
Okay, so again, we want to use the properties of exponents to determine this, okay? Somebody tell me what we can change the number 25 into with a base and an exponent. 5 what?
5 cubed. 5 squared.
Good. 25 can be rewritten as 5 squared. If 25 is being cubed, that means 5 squared is cubed, right? To rewrite 25 cubed, I could write 5 squared cubed, right? Because 5 squared is 25, and then 25 cubed is 25 cubed. Is there any way to rewrite 5 to the 6th power? Is there any way to rewrite 5?
5 to the second.
So I can rewrite that. Oh, you're saying I could rewrite it as 5 to the 5 squared times. Yeah, you're right. Technically, you don't have to, but I love that you said that because you could, knowing that 6 can be the product of 2 and 3, you could rewrite this as 5 squared cubed. You're very right. The other way that you can solve this is multiply your 2 and your 3, multiply your exponents, power raised to a power. So you would do 2 times 3 would be 5 to the 6th power, which matches that. Therefore, this equals this. Does that make sense? Okay, let's do it again.
It's only because when I put it in, I got, never mind.
Okay, so for this would be the expressions are equal. The expression 25 to the 3rd power can be written as 5 to the 6th. So number 8 is next.
I don't get number 8.
Oh, this is a funny question. It says use technology to evaluate the expression. What do they mean by technology? Your calculator. Go ahead and use your calculator. We're going to type in the number 6.
Let's use this word.
Then we're going to use our y to the x power button. And then we're going to type in 3.6.
Look at that. It don't work.
And it says type an integer or decimal rounded to the nearest 1,000.
Ain't nobody want to round that.
1,000. So I have 632.9137071. Let's find our thousands place. What place value is this?
Hold up. Where'd you get that number from?
Is this not right?
Calculator.
Did you?
That is the right thing.
Yeah,
So you type, Abby,
6.
you type in 6, then you have to hit the button that's the y to the x power. That's showing that you want to type in an exponent. Click that.
Yeah, don't you put the second button first?
No, that's if you're trying to find a root. That was yesterday when we were
Yeah.
doing this.
That's
All right, let's make sure we're rounding this correctly because it says to round to 1,000. What place value is this? What place value is this? Tenths. What place value is this?
Hundreds.
Hundredths. What's this? Thousandths. So this is the one that is either going to go up or stay the same. What do we look to figure out if it goes up or stays the same? Yep, we look to our little buddy to the right. Is the 7 big enough that it's going to cause this to go up?
Yeah.
Yes, it is. So the 3 is going to round up to a 4. So we have 632.914. For this question, you can, if you have a different number, you're going to do it according to your number. Did you guys get different numbers?
No.
You got the same one? That's good. Only 3 more questions. So this is number 9. There's too much talking going on. Number 9 says use the law of exponents, basically our rules that we follow, to simplify the expression. What's going on outside? Anything good? You guys are all looking out the window. All right, use the laws of exponents to simplify the expression. This is something that we have done before, and if you haven't had my class yet today, we are going to do more examples like this in the lesson. But it is something that we worked on with our properties of exponents. Sometimes they're called laws of exponents, sometimes they're called properties of exponents. I just call them the rules. Okay, we have a 7 to a power times a 7 to a power. What does that mean we can do with our exponents?
Multiply.
Combine the exponents. What does combine mean? Add the exponents. When you have the same base and they're being multiplied, you add your exponents. So we would simply take our 12 fifths plus our negative 2 fifths. We like that the denominators are the same. We don't have to change any fractions. So what do I have to do with my 12 and my 2? No. We are adding. We're adding the exponents. Yes. So we're going to follow the rules for adding integers. 12 plus negative 2 is 12 minus 2, which is 10. Take the sign of the greater absolute value, which is positive. So it would be a positive 10 over 5, which equals what? 2. So what's our exponent for the 7? 2. So this would be 7 squared, which would be 49. 49 is your answer.
That's where I got it
What is this?
You're still struggling.
No, I'm not. Well, like the next question, what is that?
This?
Oh, this is.
Abby, we did this today in the lesson, and we also did it over the past week. Okay, so it might look scary because there's like a fraction up here, there's a fraction here, and there's a fraction down there. We're just going to treat them like regular numbers. How about we go over the rule before we look at these crazy fractions? What if it just said 8 to the 5th over 8 to the 3rd?
We add the times then.
Subtract.
Subtract them. If you have the same base
Oh.
being divided,
Wait a minute.
you subtract your exponents. It would be 8 to the 5 minus 3, which would be 8 squared. That's the rule. Let's apply it to these ugly fractions, these ugly rational exponents. It's the same rule. We take our base and subtract the exponents. 5 over 3 minus 4 over 3. We have common denominators. That's a good thing. We don't have to convert any fractions.
1 over 8.
1 over 3. So we have 8 to the 1/3. If you type that into the answer, it will tell you it's wrong. Why?
Because you have to simplify.
Yes. How can we simplify 8 to the 1/3 power?
8 thirds. I mean 8.
Wait, what?
I'll give you
You have to do the square root.
close.
Cube.
Not, yes. Cubed root of 8 equals
Yeah.
2. And if you don't have that memorized, that's okay. There's a button for that on your calculator.
So the answer is just 2.
The answer is just 2.
That one.
How does something?
Did you guys get the same numbers?
Wait,
Yeah.
yeah, but why does
Why?
it have
So
different
what's going on with
numbers?
this that we're getting all the same numbers?
I think it's a.
I wasn't getting the same
What?
number.
It's
Well,
probably
Miss Lane,
like
those are
some
side questions.
questions that are.
Oh, is it just one? Did anybody get different numbers than that?
Miss Lane,
Huh.
that is a set question, so it's just gonna be the same root.
Some of them are, usually it's like with like word problems and stuff that we'll get the same numbers. Usually with this kind of thing, they'll generate different numbers. But in any case, we have one more. If you did not have my class yet today, you did not have a problem like this because we're doing it in the lesson today. But it's very, I don't want to say it's very simple. It is, it's manageable. But I'm going to kind of teach it as I go through, okay? It says, given the figure, find the area, I'm going to make this bigger, find the area of rectangle A. The other two labeled areas are squares. Okay, so that's really important information. It says that A is a rectangle. We want to find the area, right? We want to find the area. Now, how do you find the area of any rectangle? Good. Length times width. We write it in fancy cursive letters. Okay? Now, does it tell you, look at these sides, does it tell you the length and the width? No. It doesn't even tell you like these sides and you could like match them up, right? But we know, we'll call this the length and we'll call this the width. Doesn't matter which one is which. If they're being multiplied together, commutative property multiplication. I'm just gonna call this the length because usually we call the longer side the length, okay? So the length and the width. Okay. Now, it gives us the area of these squares. It tells us in the problem that these are squares. What do we know about squares? Yes, all 4 sides are equal. So the area of a square, you can write it as length times width because technically a square is a rectangle and you just can consider it like length times width. But since we know that the area of a square, since we know that a square has all equal sides, that means the length and the width are exactly the same. So how can we write the formula? No, that would be if 80 was the perimeter. If they said the perimeter is 80, then you could divide 80 by 4.
If you look at the sides for like the rectangle that we're trying to figure out, the side with the 45, it's the same like size as the
Right, that's because you're thinking of these numbers as side lengths or the combination of side lengths. This is area. That means that this square, this times this is 45. This times this is 80. So, I'm gonna ask the question again. This is a little bit tricky, okay? If the area of a square or rectangle is length times width, but we can say that a square specifically has 4 equal sides, or we could say that the length and the width are equal to each other, we can be more specific with our formula for a square. Because the length and the width have to be the same number if it's a square, right? So let's, instead of calling it the length and the width, let's just say a side. Let's just use S for side. So what would it be if I was, what's the area of a square? Side times what? What would I multiply a side times? to find the area of a square? Didn't we say that the sides of a square are all exactly the same? So what would if I know, say it again?
The side.
So I would multiply the side times,
Another side. Well, technically the other side.
Length times width.
what if I said the side was 5? What would I multiply 5 times?
5.
Good. What if I said the side was 6? What would you multiply it times?
It would be 8 to the
Hold on. What would you multiply, if I said the side length was 6, what would you multiply the side times? Okay, what if I said the side length was 11.2, what would you multiply the side times?
square it. Square root.
Itself,
You want to square
right?
it?
You have to square it. So it would be side times side times the exact same. That's why I can say, if I can use the variable s to represent the side length, and I would have to multiply it times the exact same value. And just as Abby said, we could say that that is the same thing as the side squared. Okay, so if the side squared is going to give me 80 feet squared, that means a number times itself gives me 80. Is 80 a perfect square? Is there a number that when multiplied times itself, like is there a whole number that you can multiply times itself to get 80? What is it? 10 times 10 is 100.
40. Wait, no, 20.
20 times 20 is 400. So remember, we have to have a number times itself to be 80. Is there a whole number that you can multiply times itself to get 80? She's saying yes. What number is it?
I don't know, but I think it's an even number.
10.
10 times 10 is 100.
Oh.
Wait, is it?
So 100 is too high. We need to get to 80, right? What's 9 times 9?
1.
81. Is that 80? No. What's 8 times 8? 64. So 8 times 8 is 64. 9 times 9 is 81. Is there a whole number that you can multiply times itself to get 80? No, there is not. So we answer that question, right? We would say that 80 is not a perfect square, even though it looks so beautiful, right? The definition of a perfect square means that it has a square root that's a whole number. And 80 can be the area of a square, but it just means that the side lengths are not whole numbers. The side length is going to be somewhere between 8 and 9, right? Because 8 times 8 is 64, that's too low. 9 times 9 is 81. It's too high, but it's really close. So it might be something like 8.92946 or something like that. Are you guys with me? That the square root of 80 is going to be a decimal number somewhere between 8 and 9. So we have decided that we can't just find like a side length that's a whole number. So we can rewrite we can rewrite the side length using either a radical, which is our square root sign, or a fractional exponent. First, let's write it as a radical. How could you write the length of a side? Like let's put the side length right here. How could you write it if the area is 80? How could you represent, what would you have to do to the 80 to find a side length? If the side times itself is 80.
80 divided by 4.
No, that would be if the perimeter was 80.
Oh.
So if 80 is when the side is squared,
80 divided by 2.
80 divided by 2 is 40. 40 times 40 is 1600.
I'm trying to figure
Write
out.
it down.
You have to.
I know why you said divided by 2. You're so close to getting this.
Square root it.
What?
Square root it.
Square root it. If 80 is the result of squaring the side, then finding the square root of 80 would give us the side length, right? Now, we just said that we can't find a whole number square root of 80. So, we're gonna rewrite the square root of 80 using rational exponents. What would that look like? 80 to the what power?
Second.
1/2.
80 to the 1/2 power. Very good. The square root of 80 is the same thing as 80 to the 1/2 power. So we're gonna say that this side, for the square that is 80 feet squared, is 80 to the 1/2 power. Also, this is 80 to the 1/2 power. Okay?
So it equals. Wait. So the two sides are 64.
No. We're not actually trying to solve for the sides.
Oh.
We're just trying to, we're not actually trying to like simplify what 80 to the 1/2 power is, because 80 to the 1/2 power is the square root of 80. If I type that in, did anybody do it?
40.
80, square root of 80 is 8.9442711 ... It's gonna keep going and going. It doesn't repeat. It's not a rational number. So we can represent it by writing 80 to the 1/2 power, because when the actual number just keeps going and going decimals. So this is the best way to write that number. How can we represent the side length of the square that is 45 feet squared?
Square root it.
Square root it, and if I square root 45, how can I write it with a base and an exponent? 45 to the 1/2 power. That would be this side. Now, I have to find the area of this rectangle. So I'm going to take my length, which is the side of this square, 80 to the 1/2 power, and I'm going to take my width, which is the side of this square, 45 to the 1/2 power, and I'm going to multiply them together. So we have 45 to the 1/2 power times 80 to the 1/2 power.
Multiply the exponents.
No, I want to do
What?
How come we did this in science? We put it in
Okay, so now we're going to start breaking these things down. Okay.
I got it.
Okay, so now we're going to start breaking these down. We have to break 45 down into a number that can be, how are we doing on time?
5.
Okay, so can we break 45 down
It'd be
into two factors? Let's try 5 and 9, okay?
Yeah.
9 can be rewritten as 3 squared. So we have 5 times 3 squared to the 1/2 power, right? And then we have, let's see, 80 and 10, 8 and 10, 20 and 4, 5, what's 80 divided by 5? Let's try to pull out a 5. 80 divided by 5 is 16. And how can we rewrite 16?
4 to the 4th power.
4 to the 4th power to the 1/2 power.
Wait, wouldn't it be 4 squared? Because 4 times 4 is 16.
Oh, 4 squared, sorry, yes. 4 squared. So now we can simplify these parts. So we pulled out our 5s, and we can simplify this. So we have 3 squared, so 2 times 1 over 2 would cancel out, and that would just be 3. So we have 5 times 3. Yes. Now, this is also to the 1/2 power. I should have written that. This is also to the 1/2 power, because if we're breaking this down, this is really 5 times 9 to the 1/2 power. This is really 5 times 16 to the 1/2 power, okay? So this is 5 to the 1/2 times 3, and then multiply that times 5 to the 1/2 times cancel 4. Are you guys with me? This is really tricky. Now, what's 5 to the 1/2 times 5 to the 1/2?
It cancels.
It doesn't cancel. 5 to the 1/2 over 5 to the 1/2 would cancel. What would we do with our exponents here?
Subtract. Add them.
Add them. What's 1/2 and 1/2? 1. So it would be what?
5 to the 1 power.
Which is 5. So 5 to the 1/2 times 5 to the 1/2 is 5. Times 3 times 4.
So that would be 15 times 4.
Or which is 60. So this is 60
Feet squared.
feet squared. I hope and pray that it is.
Yeah, it is.
Could put it in.
Can you go back to number 2?
Yep.
My brain hurts.
Yeah, I know, this was a crazy one. All right, that's it for that, and I'll go back to you off camera. I'll go back.